Have you ever stopped to wonder just how immense the universe really is? Where it begins? Or if it even has a beginning at all? Where it ends? If it does end, these are questions that have captivated the human mind for as long as we've gazed at the stars. And yet, despite our curiosity, we've never arrived at a single, clear answer. The truth is, the scale of the cosmos is so immense, so vastly disproportionate to anything we encounter in our daily lives, that it escapes the bounds of ordinary logic and human intuition. Thanks to the incredible technological advancements in astronomy and space exploration, we now have tools that offer a glimpse into the incomprehensible size and structure of the universe. Instruments like the James Webb Space Telescope and other modern observatories have allowed us to peer into the farthest reaches of space, offering faint hints about just how far it all might go. What we see out there suggests a universe that is endless, so enormous in fact, that only the most far-reaching imagination could begin to describe it. While we still can't say for certain just how large the universe is, some scientists propose that what we perceive as the universe may only be one of countless others. These hypothetical universes, part of what's called the multiverse, could each have their own physical laws, their own versions of reality, and possibly even forms of life that are completely alien to anything we know or can envision. In some of these universes, gravity might not exist. In others, time might flow differently. They might contain particles, forces, and even dimensions that don't exist in our own. We may never observe these realms directly, but the mere possibility reshapes how we think about existence. What we do know more confidently is the size and scale of many of the structures and celestial bodies within our own universe. And even these, within just this one observable cosmos, are staggeringly large. Recently, scientists working with NASA and the James Webb Space Telescope announced the discovery of the largest cosmic structure ever detected. This groundbreaking find stretches our understanding of what's possible in the known universe. To truly comprehend this discovery, we need to put things into perspective, starting small and moving toward the colossal. Take the moon, for example. It's our nearest celestial neighbor and relatively easy to picture. The moon measures about 3,474 kilometers in diameter. That may sound big, but it's dwarfed by Earth, which spans approximately 12,742 kilometers across. Already, we see an object more than 3 times larger. Then, compare Earth to Jupiter, the giant of our solar system. Jupiter has a diameter of about 140,000 kilometers, making it over 10 times wider than Earth. If we used everyday objects to visualize this comparison, Earth would be like a ping-pong ball next to a soccer ball. But even Jupiter is modest when placed beside some of the exoplanets we've discovered. Consider HD 10546b, a gas giant planet about 7 times larger than Jupiter. This behemoth has a staggering diameter of 986,000 kilometers. If Earth stood nearby, it would be virtually invisible, a tiny speck in comparison to such a cosmic monster. Yet even that massive planet is a minuscule object next to our Sun. The Sun, the central star of our solar system, has a diameter of approximately 1.382 million kilometers. It is immense beyond comprehension, capable of fitting over 1 million Earths inside it. But even our Sun pales next to the largest known star, Stephenson 2-18. This red supergiant is one of the most gigantic stellar bodies ever discovered, with a diameter close to 9 billion kilometers. When compared side by side, our Sun looks like a grain of sand next to a basketball. The scale is truly beyond words. Still, size doesn't stop there. The universe holds even more mind-bending giants. One such entity is Ton 618, an ultra-massive black hole located in a distant galaxy. It possesses a mass of roughly 60 billion times that of the Sun, and its event horizon, the boundary beyond which nothing can escape, spans approximately 390 billion kilometers. At this point, measuring in kilometers becomes unwieldy. The scale is so immense, we switch to light years. Now, think of the Tarantula Nebula, the largest nebula we've observed. A nebula is a vast cloud of gas and dust, often where stars are born. The Tarantula Nebula spans roughly 1,862 light years across. That means light, traveling at nearly 300,000 kilometers per second, would still take over 1 to 800 years just to cross from one end to the other. Yet even this enormous structure is small compared to the Milky Way galaxy, which is about 105,700 light-years in diameter. And the Milky Way, it's not even among the largest galaxies. One of the most massive known galaxies is IC 1101, which stretches an astonishing 6 million light-years across. That's nearly 60 times the width of the Milky Way. But even this gigantic galaxy can be overshadowed by larger cosmic structures. Let's venture deeper into the cosmos. There is a region known as the Eridanus supervoid, a part of space that seems almost completely empty. It spans around 1.8 billion light-years across and contains far fewer galaxies than expected. This void is one of the largest known gaps in the observable universe, but it's still not the biggest structure we've identified. Far more immense is the Hercules Corona Borealis Great Wall, a massive cosmic filament made up of galaxies and galaxy clusters spanning an estimated 10 billion light-years in diameter. To put that in perspective, it stretches across about 11% of the observable universe. Some scientists argue this may be the largest coherent structure ever discovered. But there's another contender for the title of the universe's grandest feature, the cosmic web. The cosmic web isn't a single object, but rather the very scaffolding of the universe. It's a vast network of interconnected filaments composed of dark matter, galaxies, gas, and dust, stretching across billions of light-years. It links together galaxy clusters like neural connections in a vast, invisible brain. This structure was visualized through powerful computer simulations, which show the universe not as a random scatter of galaxies, but as a highly organized, web-like system. Incredibly, this structure bears a striking resemblance to the network of neurons in the human brain. A team of scientists at the University of Bologna undertook a detailed comparison between the cosmic web and the neural networks within our own cerebellum. What they found is astonishing. Not only do the two systems look remarkably similar, but they also seem to be governed by the same underlying principles. Despite being separated by scales that differ by more than 7 orders of magnitude, both the human brain and the cosmic web are composed of about 30% active structures, neurons, in the brain and galaxies in space, connected by filaments and nodes. The remaining 70% in both systems consists of seemingly passive material, water in the brain, and dark energy in the universe. This passive material shapes the system's overall structure without directly interacting like the visible elements. Further analysis showed that the distribution of matter in the cosmic web follows a similar pattern to the distribution of neural activity in the brain's cerebellum. These findings suggest a shared dynamic, a universal principle that shapes complex systems, whether biological or cosmic. It raises profound questions. Could the universe itself be a form of intelligent life? Is it possible that consciousness, structure, and evolution operate on both micro and macro scales in parallel? When people say everything is connected, it's often taken as a philosophical or spiritual idea. But what we're learning from science is that this concept might be quite literal. Every atom in our bodies was forged in the heart of a star. Every galaxy is part of a network shaped by gravity, dark matter, and energy flows that stretch across the fabric of space-time. And perhaps, just as neurons form thoughts and awareness in the brain, galaxies and cosmic filaments may contribute to a kind of universal awareness we are only beginning to imagine. This understanding invites us to reflect on the choices we make, not just as individuals, but as members of an interdependent cosmos. Each action, each thought, each movement we take sends ripples through the fabric of our shared existence. By being more conscious of our place in the universe, we can choose to create positive change within ourselves and in the world around us. Ultimately, the universe may not just be a place we live in. It might be something we are a part of in a much deeper way than we realize. Our bodies, our thoughts, even our relationships could be threads in a grand design, woven into the very architecture of reality itself. And so, as we look outward into the vast, expanding cosmos, we may also be looking inward. Perhaps the universe is not only vast and powerful, but also aware in ways we're only starting to understand. In this interconnected web of stars, matter, energy, and thought, we are not alone. We are a vital, living part of it all.